So it's now 9:30 Friday, and before we start the weekend, I would like to welcome you all to our first community event, which is focused on a very specific use case for the edge, which is electric vehicle charging. For the next couple of hours, we have really interesting presentations that are going to bring the edge to life. Why is it a new technological paradigm that we should be looking at and care about? And we're also going to be having a very interactive panel with experts from across industry, looking at some of the specific reasons for using the edge within the smart energy domain. With me today, we have AIoTi. I'm Tanya Suarez. I am the CEO of BlueSpecs. We are one of the partners in the EU-IoT project. I'm also a board member for AIoTi. And with me, I have Dolores Ordóñez, who is from Any Solution and also a member of AIoTi and very specifically leading the working group on energy. Before we go into that, I'm just going to go through some housekeeping rules. So first of all, this event is going to be recorded and published on the NGIoT website. That means that there's a lot of knowledge that's going to be captured and that other people and you yourselves can go back and access at any point in time. The second point is that we would really like it to be as interactive as possible. So please do post your comments and questions on the Q&A session. We will be asking you to post those. Then I will mention, I'll probably pull them out in a specific order. And my colleague Valentine here from Martel will give you the floor to be able to ask that question in person. Finally, well, not finally, there are a few channels through which you can actually join the discussion online. Please do use the hashtags that we've mentioned here. And now, finally, if you do have any technical issues, then please just send an email at the info.ngiot.eu. So as I said, I'm Tanya Suarez. I'm a board member for AIoTi, but I'm very privileged to work with a very wide range of very talented people that are active in the IoT ecosystem. Very specifically with me today, I have the pleasure of co-chairing with Dolores Ordóñez. Dolores, if you would just switch your, there we go. Can we see you at least and just wave? I think you've got your camera off still. There we are. Nice to see you. So before we go into the, I'm just going to share my screens now, Valentine. We can swap. Perfect. Let me just share my presentation. And 2 seconds, there we go. Can we all see that? Yeah, perfect, thank you. So what we're going to be doing today is essentially looking at the electric vehicle charging use case as a specific instance of edge technologies coming to life and really adding value beyond what is done already. The electric vehicles market has really exploded. It grew from 10% last year of total car registrations to in 2020 to 18% in 2021. And it's a really good occasion and a good environment to really look at how we can move from a very much a cloud-centric model into a scenario in which we can look at distributed energy generation and distribution. And as I said, we've got a couple of presenters today. So Francesco from the Iot Engine Project and Dimitrios, who are both going to be looking at very different aspects of this. So Francesco is the EV use case lead, and Dimitrios is about very much about the integration piece. So looking at the architecture and looking about the evaluation as well. After that, we're going to be inviting some of our experts onto the stage, or the virtual stage. So Michael, the principal engineer for the smart energy systems from Siemens, Damien Bevan, cloud architecture lead from GemServe, and Laurent Schmidt, who is president for Digital for Grids, but who also has a very long and extensive experience working with grids generally and distributed energy systems. So that's at any point in time, please do post your questions and your comments, and we will find the appropriate time to raise those. Finally, we have with us Mariam Malafos. Welcome to you all. Very much looking forward to the engaging debate, the sharing of information, the questioning of different perspectives as is necessary, as may be necessary during the course of today. So just perhaps before we go into that, a little bit of information about the NGIoT project itself, and it's very specifically EU-IoT. So EU-IoT is a coordination and support action. For those of you who are not familiar with the inner workings of the Commission, Horizon Europe, and all the framework programs, essentially coordination and support actions are there to ensure that knowledge flows from one funded project to another and across the whole of the ecosystem, and that knowledge can then be optimized and used across generally the wider economy. The NGIoT part of Horizon, in fact this is Horizon 2020 initially, has had 48 million euros invested in it over the period 2020 to 2023. There are 6 different use cases or scenarios in which edge technologies and the cloud to edge continuum more specifically are being investigated and deployed. And if you have a look at the figure on the right, this has a very broad description of some of the topics that are being explored across all of those. So we're going all the way from data spaces, the infrastructure that enables the next generation IoT to be deployed, the near edge, the far edge, and of course the human IoT interface. So this is, I'm just going to move my panel. There we go. So what is the cloud to edge continuum? Well, we're talking about data that's being generated, stored, analyzed, processed everywhere along a continuum that goes from the user or the IoT interface all the way to the cloud and back. And there's a lot of iteration. So even though this figure is linear, it's in fact something that has very many touch points and continuity of data transfer along the different components of the cloud to edge. So we have the human, the device, the gateways, the infrastructure, as I said, that's enabling that, and the cloud servers themselves. The far edge is probably at this point still technologically advanced than the near edge, but actually it has a lot more technological economic potential. We have had very many interactions with experts across different domains, and it's really quite exciting to see how different markets are really exploring the possibility of generating and processing that data much closer to the user, to the purpose for what that for that data to be integrated and used, rather than having to send it to the cloud. And that has savings not just in terms of the energy use. I mean, draining our natural resources so that we can send data from where we're actually collecting all the way to the cloud is something that we can no longer afford. This is part of the a key principle of the Green Deal and the green transition also. So anything that we can do to make sure that that vast amount of energy that's being deployed for that purpose can be reduced is obviously to be welcome, but there are other benefits as well, just in terms of latency and efficiency, but also data sovereignty. In terms of the use cases and where the market share or where the edges is going to be most valuable, this was a study, I think it was conducted last year by BCG, and it just has a very nice analysis of some of the use cases in which edge makes more sense. So we have all the way, we go all the way from smart grids across to connected transportation. Of course, the session that we're looking at today brings both of those together. So pleased to see that that we're aligned with some of the best or most famous market predictions for this. Finally, I would like to say that the next generation IoT environment is a very open environment. So even though these projects and these ecosystems are working on architectures and on the technology that is going to be used across these different industries in the next 3 years, there are very many opportunities for people who are not within those projects to get involved. If you have any use case or any ideas for deploying these new technologies, then there are open calls that are periodically announced. And one of the ways in which we can share these is through the IoT Next Club, which is run by my colleague, John Rodriguez, who's also on this call. So we would urge you or invite you to also become members of this. So I think at this point, Dolores, I would like to pass over to you in your capacity of lead of the Working Group for Energy and IoT. And thank you very much and welcome all of you to the session today.
Thank you. Thank you so much, Tania. It's a great pleasure for the IoTI to be here present today in such an interesting event. And as you mentioned, this is also related to ecosystems. And I'm going to start explaining in very short, because we don't want to take a lot of time from this part of the introduction. What is the IoTI and why we are here today supporting this very interesting project? So I'm not going to go to read what is the mission and vision, but what we want to mention especially is the importance that the IoTI is given every time more to the connections about the different technologies. IoT and edge computing, together with other disruptive technologies, are supporting very much the competitiveness of the different sectors. And of course, it's very important to generate synergies with other initiatives as the one that is being promoted by NGIoT and all the work that has been explained by Tania, in order to promote this competitiveness in the European market. So the IoTI was founded in 2016. Those are the founding members, but this is a community that that is growing constantly. So we are working in 3 main levels. So our main themes are related to IoT or industrial IoT applications in different verticals. And we are also generating synergies with other converging technologies. So at the end, it is important very much to generate also a leadership in these disruptive technologies and to see how they can interact. And that's why we are trying to push for this leadership, also supporting all the EU policies and regulations that emerge at European level. Also, it's very important for us to generate all kinds of collaborations with the different members. We are in charge or in contacting different research entities, public entities, private companies, of course, and we try to collaborate with all of them in order to generate this IoT market and this European leadership. At the present, we are more than 200 members, and from which 118 are companies. So I think this is very important because at the end, we are generating this public-private partnership in which the different entities are working together towards this convergence in the markets. And just to have a wide idea on the groups in which we are working, you have seen that we have some verticals, and then you see there that we have a kind of a group of sectors in which we are working. So in which you will see there agriculture, health, of course, energy. We have to mention that in the working group mobility and logistics, we have a specific task force for electromobility. So it is important because the way of working in the IoTI is that we have some groups in which we work together to develop strategic agendas, papers, common European projects. But at the same time, when we discover that there is an area in which there is a specific interest, we generate this kind of task force in which we promote that all the members works together. So regarding the activities, there is one important part in the leadership area in which we contribute very much to all the regulation that exists at European level. We make a follow-up of what is going on, as for example, with the data access, standardization, or the Green Deal. We develop collaboration with different entities, with other networks, with other institutions, with other kind of initiatives that exist at the level of the European Union. Also, we generate these matchmaking events in order to promote collaborations and synergies among the partners. So indeed, we're participating in a number of European projects, and we have created more than 70 consortia. And it is important because at the end, we are up to date what's happening at the level of IoTI. So a number of deliverables in which we are working, we generate papers, we generate events, we support also these kind of events, and we are up to date on the things that are happening. So, but if we concentrate in the part of EV charging, and just to finalize, because we want to keep up the time in the agenda, it is important to mention some specific issues. So first of all, the importance of generate cross-cutting synergies. So we are in the working group energy, but we work closely with the other groups as mobility and logistics, as cannot be in other way, digital for green, and also innovation ecosystem. It is fundamental to generate synergies among the different groups in order to develop the important projects. Why? Because we see that if we go to the part of technologies, and today we are going to have panelists that are going to speak about these things, it is very important to see how the technologies are evolving in order to give an answer to the requirements and needs of the users. So in this case, we are speaking about EV charging, we are speaking about the case of the edge. Why? Because we need to have these computational possibilities in the edge in order to send only the required information to the cloud, but to offer the answers in real time. And this is very important, especially for the mobility sector. And then we are connected also with the data spaces, because at the end, it's all about data. So we are going through EV charging through the electrical vehicles. We are going to start gathering a huge amount of data, and it is important to start thinking how this data is going to be managed. And for that, it is important also to be aware on which are the regulations. So to identify which are the challenges for the user, the challenges for the provider, the challenges for all the people that is working at the different points of the EV charging value chain, in order to know which are the technological barriers, in order to know which are the maintenance barriers, in order to know which are the barriers that exist at local level, at regional level, at national level, in order to be replicated at European level, to ensure that we have a market in which the deployment of the electrical vehicle is going to be easy, fast, and everybody could use them. And also, of course, standardization plays an important role. We have great speakers today. I'm going to take more time. Thank you very much for inviting us to be here, and I will make the wrap up at the end. Thank you, Tania.
Thank you very much, Dolores. And I think that you've highlighted some of the really important things that we're going to be looking at. So very much the session today is about looking at those barriers, but also, so it's not just about the potential, it's how can we really ensure that that potential is fully met, and how can we, what needs to be done at European level, what are the connections that need to be made within the different components within the IoT, and very specifically edge to cloud continuum and back again, to make sure that this is efficient, that it's world class, and that we can continue to decide where and how data is used. So without further ado then, I would now like to invite Francesco Bellassini, who's the EV use case lead for IoT Engine. Francesco, please do share your screen.
Thank you very much.
Thank you.
Hi, everybody. So I share my screen. Can you see my screen?
We can. Do go ahead. Thank you.
Perfect. So, hello, everybody. My name is Francesco Bellassini. I'm a mechanical engineer, senior researcher, and project manager in Emotion, an Italian company that produces charging stations and provides digital services for electric mobility. Today, I will present you a quick overview of IoT Engine Project, and after that, I will move to the driver-friendly, dispatchable EV charging use case. The IoT Engine Project is a European Union-funded collaborative project aiming at unleashing the power of next-generation IoT as an essential dimension of the next-generation Internet. In the IoT Engine Project, we are developing solutions to define a scalable, secure, open, federated, and decentralized IoT meta-architecture for sensing, actuation, and smart behavior, such as streaming and processing on device or at the edge cloud. Enhance IoT underlying technology offering IoT 5G optimization and by design secure edge cloud execution environment to support microservices, offloading, and increase scalability. Enhance IoT privacy, preserving federated machine learning and on-device ethical artificial intelligence. Enhance IoT cybersecurity against data poisoning and machine learning-based anomaly detection. And finally, enforce data sovereignty by making IoT data accessible in a trusted, auditable, and controlled way. The project is conducted on 7 trials at different locations in Europe to validate the results in real time. Now I introduce you the problem that is addressed in the driver-friendly dispatchable EV charging use case. To fight climate change, carbon emission must be reduced. Fossil fuels have been the cheapest way to generate energy for the past 100 years, but fortunately this is changing. Indeed, the cost of renewable technology has dropped. Just 10 years ago, solar cost 2,023% more than coal, but in the last few years, this has changed completely. In just a decade, the price has fallen by 89%. Thanks to this, in Europe in 2020, was produced more energy from renewable sources than energy from fossil fuels, confirming that the transition to renewable energy is well underway. However, this confronts us with a major challenge, namely balancing energy production and consumption, having intermittent and non-programmable energy sources, which are strongly influenced by atmospheric conditions. For this reason, in Italy, at the dawn of distributed generation, the most practiced solution was the energy curtailment. That means disconnected the renewable energy plants from the grid. Today, thanks to the digitalization process of the electricity grid, the reaction strategy is changing. The network is equipped with devices that allow remote monitoring and management in real time. Grid owners and operators collect huge amounts of data which are processed by forecasting algorithms, which provide useful information to avoid stability problems. An application of this information can be found in demand response, a mechanism used for the temporal shift of end users' consumption based on the needs of the network, and this is where electric mobility comes into play to help the transition to green energy, providing its flexibility to the network, helping for the grid balancing, optimizing the integration of renewable energy. Driver-friendly dispatchable EV charging use case will be demonstrated in ASM Terni Living Lab in the heart of Italy by Emotion as charging point operator and electric vehicle aggregator, together with ASM as electricity distribution system operator. The use case involves 4 secondary substations, and it focuses on the medium and low voltage network, equipped with 2 photovoltaic generation plants, which often produce an electricity surplus that causes reverse power flow to the primary substation. Reverse power flow causes stability and safety problems like voltage rise and frequency imbalance. A fleet of 6 electric vehicles offered by Emotion is part of the pilot infrastructure, together with 3 smart EV charging stations. The objective of this use case is to charge electric vehicles with energy produced by local renewable energy plants, with the aim to power the e-mobility with clean energy and help DSO to keep the grid stable in a condition of high penetration of distributed renewable energy plants. This image describes the electric mobility network topology for the use case. There are 3 main networks. The first, top left, is the network to which the Emotion headquarters and charging station are connected. The second, bottom left, is the network to which the electric vehicles are connected. And the third, bottom right, is the network where the Emotion private server is hosted. Emotion charging station and electric vehicles send data to the VPS where run the EV wrapper server, the OCPP server, and the API REST. The charging station exchanges data through a modem connected to a single board computer installed inside of the charging station, and the protocol used is the OCPP 2.0, the application protocol for communication between charging station and the central management system. Also is used the WebSocket, the computer communication protocol, providing a full duplex communication channel over a single TCP connection. The charging station data format is JSON and the sampling rate is 1 second. Regarding the EV monitoring, we use an onboard diagnostic device, an OBD, to retrieve data from the electric vehicle. OBD is an IoT component based on Raspberry Pi 3 and Carberry. Carberry represents the link between car electronics and Raspberry Pi, which allows the development of end users applications. OBD utilized a TCP IP communication to a TCP IP server. The network connectivity of the OBD device is via SIM, data SIM, thanks to a Raspberry Pi module that works as a modem, and the server is a Python software. The OBD protocol is MQTT, and the sampling rate is 5 seconds. The output data format of the OBD is an ASCII string, and when the data is sent to the server, it is reorganized into a wrapper, thus obtaining a grouping of the data in a JSON format. Here you can see the sequence diagram of the use case. The interaction between the DSO, the distribution system operator, and the CPO, the charging point operator, will be via blockchain-based demand response marketplace that enables smart contracts and micropayments. DSO will provide real-time data collected from smart meters distributed into the grid. Elaborating those data and weighted data via a machine learning tool will be obtained in advance the necessary amount of energy flexibility. Through the demand response marketplace API, a flexibility request will be sent from DSO platform to the e-mobility platform. Thanks to the machine learning forecasting system, also electric vehicle aggregator will acquire a prediction of the electric vehicle fleet energy flexibility provision potential amount, allowing to understand if and how it is possible to satisfy the DSO request. If acceptable, the necessary number of electric vehicles are selected to be involved in the demand response campaign. A flexibility provision confirmation response is sent to the DSO via the demand response API, and a smart contract is performed. Thereafter, electric vehicles will be directed to provide energy flexibility at the indicated charging station at the settled daytime. Through the smart meters distributed into the grid, will be possible to verify that the supply of flexibility has been provided correctly, and following the verification, the micropayment will be performed. In addition, a novel augmented reality interaction mechanism between charging station and electric vehicle will be tested and validated in the Italian Living Lab. Deployed electric vehicles will be equipped with a camera to train machine learning tool to detect charging station via computer vision. Charging station discovery and indexing will trigger the charging station access control, allowing charging session management in augmented reality mode. With this, I conclude my presentation. I invite you to contact me via mail for more information regarding both the Emotion solution and the IoT Engine project. I thank you all, and I give the floor to my colleague Dimitrios. I wish you a good continuation.
Thank you very much, Francesco. That was very interesting and set the scene wonderfully for Dimitrios. I think that you can start sharing now, and you have a tough act to follow here. So I think that Francesco made us really understand why we should be looking at this very specifically for EV charging, but also for energy more generally. So over to you now. Thank you.
Exactly. Thank you very much. And thank you, Francesco, for your presentation. Just allow me. I hope you can see my screen.
Yes, we can. Thank you.
Okay, stop the video just for the bandwidth, to save some bandwidth. So hello, everybody. My name is Dimitrios Kias. I am a computer engineer and a senior researcher for a company Intrasoft. The company Intrasoft is an IT solution and services group provisioning, and also in the context of IoT Engine Project, I'm responsible for the integration and validation activities of the developed components and of the IoT Engine platform that we built. So to continue from where Francesco left it for, we have to consider what we would like to achieve. And here is the initial IoT Engine meta architecture that we try to through this figure we identified a lot of functionality that we need to provide through our platform, and also the architectural patterns that are described in the left side of this figure, in the left vertical, that we would like to incorporate in our architecture. And on the right vertical, you can see as a security, interoperability, scalability, etc. The quality, let's say, vertical, that the functional groups described in the middle section of the figure, we would like also to achieve this, to have in mind these qualities. IoT Engine platform is also focused on several other use cases. For example, for the smart city and smart agriculture. For the smart city, we are implementing a use case for the traffic prediction, for smart agriculture, for the precision farming scenario, and also for the smart industry, a scenario that also allows us to identify objects and avoid collision problems solved. In the middle, we can see specific functional groups that the application, that the platform addresses. We can see that the workloads, for example, starting from the beginning, from the top of this figure, that describe how the workload is processed and addressed within our architect platform, and this includes services as an application or microservices, and also we tackle the issues from the middleware and to the data storage and handling. On the right side, we can see application for the analytics provided by the platform, and also for the automation section. And also in this figure is described the functional group for the federation of the data, and this is responsible for addressing the scalability and availability and stability of IoT services, and also to address the data sovereignty in a transparent, let's say, control of the data. On the right, we can see the things that we have considered as the IoT device, let's say, of our platform. And this includes also the digital identities and the smart devices that can be smart meters or even smartphones, for example. And also big issues to try to address our infrastructure, and we had to consider it beforehand a lot, is the infrastructure that our platform is based on, and it is also comprised of a cloud part, the edge part of the infrastructure. We provide the services in a containerized manner and the relevant components. So we also had to address the issues regarding the orchestration and the management of these components and the services, and also, of course, the 5G network that powers and connects the IoT devices to our infrastructure. In addition to this figure of the meta architecture, here we have, let's say, the functional stack that IoT Engine platform provides, and these are pieces of information, of functionality that can also be deployed in an IoT device or on the edge and cloud node. In different color, we can see different functionality groups, starting from this it's red color, let's say. We have the augmented reality and the tactile internet application software. With the purple color, we can see the big data analytics and the machine learning functionality that is provided by the platform, including the model serving, that is the component allows us to set and deploy a model to a device and on the edge, and also the privacy preserving, for example, federated machine learning and the deep learning also services. Also, big, let's say, focus and objective of our architecture is the data sovereignty part. And for this, we incorporate the digital twin, of course, that enables the connection between the device and the platform, and the distributed ledger technology that allows us to pass, let's say, and to audit several pieces of security information that concern devices and connect different ledger technologies. And finally, moving at the bottom of this figure, we can see the microservices that are deployed in a secure edge environment at the edge exactly. And at the bottom with this brown color, we can see the 5G network and resource management functionality and applications that also include the communication between the device to the edge. We can address this functionality as a machine-to-machine or machine-cloud-machine communication, and also the optimization of the specific environment, let's say, and through dynamic slicing and 5G network management. So this is the architecture. This is the component level, let's say, architecture that we have defined for the Iot Engine platform, and describes the platform itself. The colors in this diagram, as you can see on the bottom left of the corner, are groups of components to provide specific functionality for tactile internet, AI and machine learning, data sovereignty, the microservices, and also the security, and the 5G communications that are utilized for communicating between the device and to the edge. So this is a complete infrastructure. The communication with the device is performed through a digital twin, you can see on the bottom left, and the device recognition and indexing and the service access provision are provided through this deep, rich red color components on the top of your screen. It is worth mentioning that edge computing allows us also to address the security issues that is needed for the devices that are connected, and this is happening through the vulnerability crawler that we crawl a device that is registered in our platform for vulnerabilities, and also we can deploy, for example, honeypots, and also to detect malicious attack intrusion attempts through the relevant machine learning components now. So the top part of this figure concerns the tactile internet operations that are provided by the platform, and this also includes some augmented reality applications that allows us, for example, through a smartphone to detect objects and operate specific specific services. At the left of our screen, at the bottom, we can see the interledger part and the self-sovereign identities that are software identities, immutable identities that are used to validate the authorization of the access of the user of the device. And the purple part of this diagram concerns the machine learning provided, the machine learning as a service, the deep learning also functionality provided for training the relevant models, and finally for deploying these models either in the edge or on the device itself, given the performance characteristics are met. At the bottom right of the corner, we can see the 5G specific components, communication components, and these also drive, let's say, the secure edge cloud execution environment where many microservices are deployed there, and these microservices are utilized by the IoT devices. This environment can be optimized through 5G characteristics and to meet specific quality of service requirements. So in our specific use case for the energy use case and for for the charging vehicles, the use case. Here are the components that are actually utilized and demonstrated through our will be demonstrated. And worth mentioning, this particular figure showcases which components of those are deployed on the edge, which components could be deployed either on the edge or in the cloud, given a specific scenario. And so the specific components, as you can see here, that are deployed in the edge could be either the model itself, the machine learning model, that there's specific functionality, and these services are provided through our tactile internet, let's say, operations that is illustrated in the top part of the screen. An additional thing that I would like to mention is that given the scenario, the deployment, the specific deployment and the placement of these components could be different, and so we can move closer the model to the device if that's applicable, or have the inference part taking place in the edge computing, let's say in the edge area. And also we can have, for example, the offline training for these models taking place in the cloud, and this can also change. And also the digital twin part, that basically the digital twin is a digital representation of the physical device. This can also be placed either in the edge or in the cloud, given the service and the application that we would like to achieve at each time. So all in all, what edge computing enables us is to have this real-time data communication. And this is being solved through 5G communications, and through the data processing that is being done near its source. We can have rapid data analysis and data and inference services. Also, something that is also addressed is the privacy, the sensitivity of the data is also something that is addressed through and enabled by the edge computing, as the sensitive data can be stored locally and not communicated through the internet to a large cluster, let's say. And this also improves security. But security also gives us some more challenges that needs to be addressed in an effective, let's say, edge computing scenario. So all in all, what we do in IoT Engine is building the tools for the machine learning and machine learning as a service to build specific models for specific use cases, as the energy ones, and this is enabled through the digital twin, the communication provided with the device. We build application for tactile internet, for augmented reality, and for operating, let's say, services in an augmented reality scenario. But also we build tools for the cybersecurity part of the connection between the device and the edge. So this is something that we have to take into consideration and address it, and also the 5G communication optimization that is very important for specific quality of service, let's say, scenarios that we need to also address. And of course, we are open to apply applications to exploit more of these abilities that Edge gives us, and this is done either by specific tasks in IoT Engine that build applications on top of our platform, and also by the applications and the tools that open calls participants, let's say, provide to the platform, and allows us to test and even more our platform. Yeah. So thank you very much for your attention.
Thank you very much, Dimitris. That was very interesting. I think in that last slide, you brought together several of the elements that we were talking about and discussing when we were presenting this session generally. So the tactile internet is very much about that human IoT interface. It's the next generation of how we interact with data, with applications. How do we get devices to do what we need them to do? Do we need to even know that there's a device there? So the tactile bit means that there is that interaction, but there may also be a scenario in which it's much more about the sentient environment where we don't even realize that there's something there that we do engage with. So super interesting. And I think that the reference architecture there's a lot of content that can be reused, not just in the context of distributed grids and smart energies and very specifically electric vehicle charging, but as you say, for other applications within the smart industry arena very specifically, but across very many others as well, you know, like agriculture, so many domains in which the richness of the work that you and your colleagues have done can be captured and reused and repurposed, and we can collaboratively continue to push the boundaries of serviceable knowledge and applied knowledge. So thank you very much for that. I would now, thank you. We're going to explore some of the things and the issues that both you and Francesco have raised through our next panel. So we're going to be looking at, is the edge worth it? There's a lot of work that you can all see has gone into this. This is not just something that you can copy paste from existing architectures, or that can be so easy. I mean, despite the you know, the massive work and the skill with which Francesco and Demetrios have presented the apparent simplicity around the edge and electric vehicle charging, this is something that is incredibly complex, that takes a multitude of skills and actors to really come together, discuss, agree upon, and then trial. You know, we've just seen one instance, which is a living lab in Italy. There are others. There are, you know, 7 different locations in which the IoT Engine project has deployed this knowledge and is starting to really understand what the barriers are, what the obstacles are, and what needs to be done to make this a reality, not just within this scenario, but in others, as I've just said. So we're going to be exploring this in greater detail. Joining me now on this virtual stage are going to be Michael Metzger, Principal Engineer from Smart Energy Systems for Siemens, Damien Bevan, Cloud Architecture Lead for GemServe, and Laurent Schmidt, who's the President for Digital for Grad. So if I can invite you all to put your cameras on, please. And Federica, we could stop sharing that, please. That would be fantastic. Thank you very much. Before we go into this, if I could just ask you maybe just to give us all a little bit of background, because I've just said what you're doing at the moment, but you are all renowned experts in your field. You come with so many years of experience of working, not necessarily just within the energy system itself, but understanding how the technology that's underpinning the distributed grids as we're seeing them now, and the very specific market evolution with respect to electric vehicles. So Michael, if you could just maybe in 60 seconds explain a little bit about your background and why everyone should be listening to you and your views today. Thank you.
Yeah, so thanks for the opportunity. So I already joined 2000 Siemens, so therefore, as you already said, that I had several positions and several application fields. More or less, the big issue is automation and optimization of technical processes. Everything around energy, so meaning energy intensive demand sectors or integration of distributed energy resources. So the last years, I'm not within a business unit. I'm within the central R&D department of Siemens, so personally located in Munich, and dealing with all kinds of challenges coming to integration of renewable resources, focused on the electrical grid, but not only. The issue is that we have to bring together the different energy sectors, so being the thermal ones like heat supply with the electrical one, and then also the mobility sector. And using the flexibility we have is necessary to keep the costs for the transition into practicable ranges. And that's mainly what I'm doing the last years in pilot projects, but also with system studies where we like to get a better insight what the requirements are for our products.
Thank you, Michael. And I think that you've hit on something that Demetrios presented also, which is the issue of cost. Never has this been, or rarely has this been, such an important factor for industrial competitiveness, very specifically, but also for all of us as consumers, right? You know, it's the electric vehicle ecosystem involves both public sector actors and actions and ensuring that infrastructure there, but also as consumers, if we own an electric vehicle, making sure that we're able to power that vehicle is a very key consideration for the evolution of the market moving forward. So Damien, if I could ask you now also to present yourself and tell us a little bit, well, the potted version of your extensive experience and curriculum to date. Thank you.
Yeah, so hi, I'm Damien Bevan. I'm a principal consultant at GemServe, who is a digital services provider, and I'm the cloud architectural lead at GemServe within the digital services practice. And within that practice, we've worked on more recently, I guess, the more sort of digital transformative use cases. So where industries, businesses are looking to transform digitally and move into the more modern way of working. So we look more holistically across business rather than focusing on one particular aspect. But my, I guess my specialization is in cloud and integration and cybersecurity as well. And in GemServe, we have quite a rich history in terms of energy and our involvement in it, heavily involved in the energy regulation within the UK, running many of the energy codes. The MRA recently moved to the Retail Energy Code, a large project there in moving and modernizing and digitally transforming away from what was quite a slow moving, not particularly friendly way of managing codes into a much more modern way of doing so. And at GemServe also we work not only in energy but across other sectors as well, including health, public sector, and obviously more recently moved into low carbon and electric vehicles and so on. So we've got quite a breadth and depth of experience within GemServe, so covering lots of bases off.
Thank you, Damien. And I think that you've touched on a couple of things that are very, very pertinent to this. So first of all, the cybersecurity question. I think it was Dimitros again who was referring to the need to make sure that the architecture has a whole load of functionalities that are at design stage, very much focusing on cybersecurity and ensuring the resilience of the systems because of the, beyond critical infrastructure. This is something that is going to be put into question or called into question on an ongoing basis. Cybersecurity issues and concerns are not going to go away anytime soon. And the other thing that I think that you mentioned just there that's really relevant is energy codes. So making sure that practitioners are prepared for what needs to be a massive deployment across Europe is absolutely critical. So again, ensuring that best practice is there, that whether it's standards, hard or soft standards, but everyone is able to work to norms and to a common vision of how this needs to evolve, also absolutely critical. And that's probably also something that's going to be evolving, and we need to make sure that the mechanisms are there for people to refresh their knowledge as new capabilities and functionalities and even infrastructure changes appear in the market. So thank you very much for that. Laurent, if I could ask you to introduce yourself again. Thank you.
Yes, so good morning to everyone, and thank you for the invitation this morning. So I'm 25 years a veteran into the energy industry. I've been working with Alstom GE as the head of the smart grids activity for several years. 5 years ago, I've been moving to ENSOE, so the Association of High Voltage Grid Operator in Europe, where I was the Secretary General. I did work quite a lot onto grid codes, market codes, and clean energy package, Green Deal, and so on. And then 2 years ago, I decided to switch back into the industry, created my own company, Digital for Grids. We are working in particular on architecture for grid management in the context of distributed energy resources, so distributed energy resources integration. And I've been in particular focusing on the topic of vehicle to grids, working a lot with a Canadian startup, Decibel, with introducing a new concept of home energy station, which is based on an edge IoT platform, and learned a lot from that perspective on how to bridge IoT environments with grid operator environment, which is quite a challenge for the moment.
No, absolutely, Laurent. And I think that another challenge, and you mentioned it, we'll come back to this question, is the difference between the medium and low voltage network and the high voltage network. So I'll come back to that towards the end of the panel. If I could ask all attendees, please, if you could just rename yourself if you can, and just put the name of your company or affiliation next to your name. That'll be really helpful for when we're calling out the questions to the panelists. So I think my first question, Michael, if we could start with you. Why is the edge so important for electric vehicles? I mean, you've seen a myriad of different environments and paradigms relating to distributed systems, to energy deployment across multiple sectors. But why specifically is it so important for electric vehicle charging?
Yeah, so the part that I can judge about and I have experience is the integration of the electric vehicle into the grid. So everything around smart grid. And there one has to say, probably the most keywords are already stated on the slides we've seen. So it's about being near real-time or real-time, having a resilient system, being able to store and pre-process data near their data source for different reasons. It's because the limited bandwidth, it's also because data privacy, and it's because that we do have quite a sharp split in our system between the regulated grids and the, let's say, unbundled markets. And we do have, with the grids as a critical infrastructure, we do have requirements, and we do have an operational technology, OT, which do have other requirements. So we need something in between. And some ideas of edge computing are quite old. So in the grid automation, we see these things of local intelligence, local pre-processing already for a long time. But I would say the potential now coming to the table is that we introduce a new abstraction layer that allows to migrate functions on different devices in different levels, which gives a flexibility that is really needed. Especially for electromobility, I think doing it the old way, simply installing transformers, new cables, and so on, will have an exploding costs and also will not be able to do from a time scale. It takes too long, especially in Germany. We do have long times for planning. So we need this flexibility. And that's why edge computing is so important in this area.
Thank you, Michael. And Laurent, I saw you vigorously nodding your head there. I'm not quite sure whether it was the lengthy amount of time that it takes to actually deploy the physical infrastructure, or whether it was to some other comment or view there that Michael had. But I would like to invite you also to provide your views on that, please.
Yeah, so I think we are really at the beginning of an unprecedented growth of renewable. The easy path of renewable integration has been made. So we've reached on average 20% of renewable in grid. So this was the easy time. And what we want to do is probably multiply the pace of integrating by 4 or 5 over a very short period, and which means moving to 100% potentially. And so it's clear that the infrastructure will not be able to scale, as what Michael was saying, at the pace of what's going to happen, whether it's for EV or even distributed solar PV into home. And so that's where basically the new domain starts. It's basically how to reorganize the marketplace so that flexibility is valued in a proper manner. And basically each of the devices and distributed energy resource at the edge of the system, in terms of power, edge of the power system, can interact with each other through real-time and real-time price. And so that's what's going to be scarce in terms of resource in 10 years' time is actually the grids. So how are we going to share the scarce resource of the grids across these various layers of systems?
Yeah, and just to follow up on that question there, because you introduced the issue of a market. This is a multi-sided market, so we're going to have consumers, prosumers. This is what you're saying, that new grid needs to also facilitate that multi-party interaction.
Yeah, so the market is also going in a major evolution. I think our current market, let's be honest, is obsolete. We see it in the discussion right now around the Green Deal, around the Repower EU, and it's all about how to put consumer at the center, how send price, real-time prices to individuals so that they interact themselves and not the traditional generating plants, which are less and less. And basically how to reorganize and reorchestrate these market transactions. So I do foresee a major market uplift in the 2, 3, 5 years to come. UK is a very good example where the government wants to do things extremely fast now into implementing new regulation.
Damien, QU, I think now.
Yeah,
so,
it's interesting. It's a nice segue there into what the UK is doing and the challenges that have, I think, been realised really. The UK are doing a lot in terms of understanding what the strategy is for EV charging, infrastructure in particular, what's needed, and they've certainly recognised that the pace of rollout for the infrastructure is too slow, particularly in terms, you talked about how the new vehicles, new EV vehicles, the rate of purchase is increasing year on year. And just getting larger. So how do we cope with more EV vehicles if the infrastructure doesn't support it? So there's the pace of rollout of that infrastructure, and then there's obviously the business case for what's the commercial reason for deploying infrastructure, what's the business benefits, and I think that needs to be incentivized in a way that people do invest in the infrastructure. But again, there are challenges there, but depending on where that infrastructure is being deployed, whether it's in large cities, which is sometimes easier, or whether it's in more rural locations, which makes it much harder to install that level of infrastructure. There's some interesting cases where EV charge points have been installed in certain locations, but the grid isn't there to supply the energy for those particular charge points, so they can't actually be operated. So there's a number of interesting challenges, I think. But what's really good, particularly in the UK, is there are lots of initiatives. There's the NZIP Net Zero Innovation program that is looking at funding and bringing these kind of things forwards, and to ensure that these initiatives, I guess, are being thought about, but also being invested in as well. So I guess we get on to how those things will be done, but through things like funding and grants and so on, and incentivization to put this infrastructure in place.
Yeah, thanks, Damien. Let's move into perhaps a little bit more of a philosophical discussion of exactly where the edge stands in relation to electric vehicle charging. Is it at the charging points? I mean, you were discussing, or you were just introducing there, the point of the charging point in a rural area. Is it there? Is it in the car? Michael, from your perspective, where do you think the edge is located? Can we distinguish between the near far edge? Because this is something that, within EU-IoT is something that we're always talking about. The near edge, the far edge. Where is the device? Where's the human interaction, etc., etc. From your perspective and your experience, where is the edge?
Yeah, so probably there is no clear answer. So as always, for sure we need the edge at the infrastructure side. As already discussed, because we do have this interface between regulated grids and the market, but we also need the edge at the customer side. So, and this both will come true. How it exactly will come true, I cannot say. My expertise is more on the infrastructure side, and I'm sure that definitely this will come. And I also see that the infrastructure needs data information that's also coming from the car side, for instance. Therefore, so sitting on the infrastructure, I see that both will develop, and I see that probably we will have some diversity. What is directly on the device? What is the edge node? So I think there are different application scenarios, and for some applications, it's suitable to integrate functions directly into devices, for others not. So therefore, sorry, I cannot say the one or the alternative is that we should aim for. So.
No, and it is absolutely a complex ecosystem. I think the I think I do have it. So if you all remember, this is a very unprofessional way of doing it, but if you all remember that slide, that I can't remember, I think that was Francesco's slide about the cloud, sorry, the IoT engine architecture. It's incredibly complex, it's incredibly rich in terms of functionality, in terms of devices, even in terms of the different types of infrastructure that need to be brought in to really understanding where those connections need to be made. Laurent, do you think that there's a risk that we end up with a lot of proprietary architectures if we don't do things like IoT Engine, or do you think we should just let the market do what it needs to do and may the best architecture win?
So there's a combination of both, I think. I think, first of all, what I was saying is our regulation is kind of obsolete, so there will be a lot of change, but you cannot restart from scratch, from zero, so it is transformational. We cannot switch off the grid and restart it a few years later. So the question is, how do you manage this transformation? I would like to come back a few minutes to your previous question, which is a very interesting one. And I do see, and I have the same view as Michael, that for the moment, there are two different edges, potentially the car or the charging points. But this is because the car is offering very limited services back to the grid for the moment. What we see in the new generation of EV, a lot of cars are going to become bi-directional V2x. That means basically the interaction with the car and the grid is becoming much more complex. And the grid security element, I think, will show up, because if you have a V2G car in a home, and if you don't control it well, you can put fire in your home very easily. And so that's going, I think, from a physical reason, switch back the importance of the edge onto the charging point, especially on DC charging. That's my really my impression of the survey, which what I've done on the last 2 years, and the speed to what I see DC charging coming back into play when you have V2X, and the risk and the safety issues related to that bilateral charging. So I think we're going to see some evolution more towards the charging point than towards the car in the future. To your question about architecture, my concern is today, let's be honest, every vendor has his own IoT architecture, his own IoT blocks, tools, including ourselves, including Decibel. So the question is basically, on one side, we don't want to levelize this innovation. We don't want to get rid of this innovation. And it's good that vendors are basically putting their innovation with various technology bets and so on. But at some stage, there are critical components, whether they are in the cloud, whether they are into microservices, whether they are into the edge, into which needs to be able to interact with each other. And basically the dream of a single entity selling his IoT to the entire system is just not going to be feasible. It would be way too risky, and it would be a major bottleneck into the architecture. So what I think is very important is to bring back basically the historical architecture which have been built into the grid environments, and talking about historically SCADA, which are the very, very old style cloud-based system used in the grid operator environment, and bridge these with the new basically microservice containerized based environments, and bring better virtualization and define layer to be able to exchange data across this environment. That's very, very important. And also define what to protect in terms of data. What is the private data? What is the public data? And what are the interfaces between these various environments? That's where I think our two environment of grids and energy and IoT needs to come together shake hands and be smart in the way of connecting the two environments.
Aaron, you've just opened up a whole load of different issues there in that very brief period of time. I'm just going to name some of them, and then I'll come back because we need to explore some of those in more detail. So, you know, you're talking about, for example, microservices, which is also about connecting those heavily regulated players with unregulated players. So we'll come back to that in just a second. You spoke about containerization, virtualization, and I can't read my writing now. Oh yeah, protecting data. So we'll come back to all of those issues because they're all super important and things that really do need to be taken into account, but very specifically on the issue of security. And Damien, here, we're not just talking about cybersecurity. Laurent raised the issue of your house burning down because the current isn't the current that you need to. I mean, we had a conversation, my colleague Brendan, who's in the audience, with a local authority that essentially had deployed some infrastructure, and the charging costs were higher than they thought they would be because of the need to change the current, basically the modeling had been incorrect on the basis of the DC charging, etc. Yeah. So very specifically on the issue of security more generally, not just cybersecurity, what do you think that can be done there? Yeah.
So maybe we're talking about security. I mean, an interesting point is security of the grid, right? Security of the energy supply. How do we smooth out the peaks? How do we make sure that energy is available when it's needed? How do we store excess energy when it's available? And you know, we've seen that EVs have a key role to play in this. We talked a little bit about vehicle to grid, so that bi-directional flow of energy. So the prosumer model where vehicles aren't just consuming energy, but also providing it, and we can start to think about EVs more of batteries on wheels, so we can drive these batteries around, and we can plug them in various places where they're needed. If they're autonomous vehicles, they could potentially in the future drive themselves to where they're needed in order to balance the grid. But in terms of understanding where maybe you need to put the infrastructure or where there's load on infrastructure, that all ties back into data, I suppose, and understanding usage patterns. So building that rich picture of, and that's something GemServe have been involved in recently, is understanding where EVs are being used, where charging is taking place, where journeys are happening, and therefore, how do you plan where you put your infrastructure? Well, we can base it on what we know about common usage patterns and where the energy is required for them. At a more sort of physical level of security and cybersecurity, I think edge is interesting in how it is secured. Traditionally, when we work with cloud, the cloud vendor typically, obviously, there's a shared responsibility model in the cloud. So who is responsible for what? And typically the cloud vendor is responsible for ensuring the cloud environment. The physical premises, people can't get into the cloud environment and start interacting with it. With edge devices, it's a lot harder because these things are not protected in the same way. You don't have perimeters around these things. You know, people can break into cars, for example, tamper with them, or any other edge device in that regard. And it's also interesting to think about. We talked a little about where the edge is, and I agree with Michael. It's not one place. It's very much a blurred line, all the way from the end device itself. So what we traditionally know as IoT devices, where they traditionally do their processing, to more towards the near edge, which when we talk about 5G, that's brought with it a lot of new capabilities. It's not just about faster communications. It's also about having that processing in those 5G areas, those regional areas, the processing capability and storage capability. So you can start moving some of that processing you were doing IoT devices, not all the way to the cloud, but into those near edge areas and do your processing there. So you get your near real-time performance. You don't have to worry so much about keeping your IoT devices up to date and modern, because maybe they're not doing as much processing as they were. You can offload some of that onto those near edge devices and do it there. So you haven't got to worry. You know, it's always difficult trying to keep your edge devices up to date. There's always a limit to how much processing you do on those devices, how much storage they've got. So this kind of shifts some of that responsibility to the near edge and solve some of those particular problems.
And as we used to say, there's an app for that. We do have actually within the IoT Next Club, there's a startup called Ashvin IO that do all that pushing out of security to devices across the edge. So there's a huge market there, a nascent market for new solutions to address these new problems that are going to become perhaps they'll be bigger than we're currently kind of envisaging them at the moment. So Michael, let me come back to you. How ready are we to deploy edge on a massive scale? I mean, it's, we spoke about, very specifically, you raised the issue of the cost of rolling out infrastructure. That's not going to be, feasible to continuously upgrade, all of our networks across the whole of the European continent and globally. So how ready are we really to kind of address things perhaps on a more local level where those capabilities are needed?
Yeah, first of all, I would agree. I think what is currently has been said, that we do not have to change everything. So we have to focus on the most critical things. And to my opinion, it's the lower end of the grid. So we already talked about low voltage or medium voltage. So that's the part where the old solution with the SCADA systems, the control centers, are not able to deal with the new time of complexity. And there we need a solution, and it should not take too much time, because the challenges are coming either from electric vehicles charging, and I think this is the most urgent thing, and that's the reason why we're talking about today. But there is also the heat side, and the cooling side in other areas, which will have stress to the lower end of the grid. And there, I would say, we do have we have a lot of pilot projects in Europe, at least what I know, and I know also in other areas. For instance, in the US, we have technology that has been proven to some extent that the principal technical functions we can manage, but at the end, then it's to get the business case running and to handle the complexity of engineering, and that's often a hurdle to get it really to a commercial success. And that's, I think, where it's not so much the deep. So for sure, there are also highly interesting and challenging technical problems we still have to solve. But to start, I think it's often not the technical side, it's the business side, the business model, and then also the regulation. So I just finished a project where we build up a local electricity market in a grid, and using digital ledger technology, using market and optimization. So this from a technical point of view, this works, but the market regulation today does not allow to have a positive business case for any of the stakeholders, and that's one obstacle for rolling it out and making it a scalable business. And I think this is something we have to work on, and it's especially challenging because it's not only one stakeholder. In the old world, we had a few big players we have to convince and bring everything to work, but now we do have an end customer centered world that is coming up, and we have to deal with this, and it's not only the technical challenge.
Thank you, Michael. So there's a very clear obstacle that you've pointed to there, which is regulation, stopping essentially the financial incentive for new players to come in to kind of develop or to deploy their models on the basis of what's limiting or that regulation that applies at the moment. Laurent, is this something that you would also agree with? Are there other things that you think are
there is no doubt.
that? Yeah.
Regulation gets obsolete, and we need to get it fixed. I'm one of the experts in the Acer group working on flexibility market, and we try to fix this through the next flexibility code. Hopefully it's going to improve. What I would also like to say is beyond the regulation, there is also the need to migrate the backend system. The OT system from the DSOs and TSO are also themselves very often obsolete. And the new world where we are in is really a system of system world, where we exchange data and we exchange price signal much more than controls. And basically into that environment, the edge device is ready, I would say. That's what I realized when I looked at Decibel V2G charger and so on. What is not ready is basically aggregator and people being ready to do transactive controls and I would say interact across devices through prices and real-time prices, rather than the traditional control and command central SCADA-based, which is simply not going to scale in the future of a distributed energy system.
Really interesting. So the scalability there is limited very much, but then again by the business model. Yeah. Again, I'll come back to that. I just want to bring in Damien for this initial kind of view on obstacles and challenges that remain and that are preventing that massive deployment of edge for EV. Yeah,
so I you know, both Michael and Laurent have both talked about regulation, energy regulation. So yeah, obviously regulations there for a reason, so that people understand their obligations in terms of the energy markets. But yes, it certainly can be a blocker in terms of innovation. It can be quite slow moving traditionally. And what's quite interesting is, you know, we have been involved in the project where we move away from the old slow moving ways of managing codes into the newer, more digital way of managing codes. So everything is done digitally in terms of UK energy, retail energy code markets management. So that part of the process at least can move faster than it could previously. But I agree that it isn't particularly fast moving. And I think there are, you know, Michael did say it's not just about the technology, but there are certainly technology challenges. Edge is relatively new as a workable concept, should we say? You know, the idea of edge has been around for a long time, but actually being able to build and deploy to edge is a relatively new concept, in the same way that cloud was relatively new, sort of 5, 10, 15 years ago. So we've learned a lot in terms of cloud and how we manage cloud in that period. We haven't learned as much about edge and how to manage edge in that period. So we're kind of coming across these problems now. A lot of them to do with scalability. How do we manage rollout to hundreds, thousands, millions of devices in a way that isn't going to overwhelm and overload systems? How do we do this? You know, how do we package up distributions? We talked a little bit about Docker and deploying these containerizations, which we currently do in cloud. That's, you know, well known how we do that. But how do we do it on edge devices or near edge devices? You know, these 5G compute resources that we have. There needs to be similar models for those in terms of deploying, so that these things don't become bottlenecks and it becomes another management plane through which we manage these devices. It doesn't become a new way of doing things. So I think we've got a lot we've learned in terms of managing cloud that we can now take into edge.
Thanks, Damien. I think on that, when we were preparing these sessions, Dolores was talking about, you know, the very specific challenges around when public deployment of some of the EV charging, and very, very, very concretely the issue of maintenance of these points. That one thing was obtaining the funds to actually make the installations, but then, you know, you had to make sure that the business models were there to ensure that they were properly maintained, because obviously, you know, if somebody's going to go to a fairly remote area and expects to be able to charge their vehicle and they can't, that is not a minor problem to have. That is, you know, that can essentially, you know, make the whole market kind of, you know, put it into question. So I think that we're kind of running out of time a little bit. I've got one more question, and then I'm going to ask the attendees to pose their questions. We already have two questions in the chat. But my final question or questions are around our relative position in Europe with regard to edge technologies, but very specifically with regard to the rollout of electric vehicle charging infrastructure, and how the edge is kind of enabling that. You all have a world view of what's happening within this field. Laurent, as you've had a lot of interaction with Canada, maybe I could ask you to start on that. And just to say that I think that it's really important that we don't just believe our own hype within Europe, that we're able to really see where we're good, where we do have a competitive advantage, but to not, to also look outside and say, oh, actually, these people are doing something really well, or this country is doing something really well. We need to learn from that and make sure that we're adopting that as well. So Laurent, if you could start, please.
Yeah, so basically what we see is the new competitive edge of these, I would say, smart charging is really V2x. That's what we think is so we really monitor very closely what happens in the V2x space. And here we see the really kind of UK and California together having the lead. And they have the lead because there is a real need in California because of fires and all that kind of things. In the UK, I think it's more driven through Innovate UK and all the innovation going from there. And the fact that the Nissan Leaf, the car, is coming from the UK, which is an interesting element. What is interesting in the next deployment phase is the majority of OEMs on the EV is still coming from Europe. And so the next wave is definitely coming from Europe with very strong commitment from OEM like Volkswagen toward this technology. So that's going to rebalance. And so that's the other element is Tesla is firmly opposed to this next step, which I think will not make them an innovation player into that space. So that may also rebalance innovation across Europe and US. But my guess for the moment is UK is going to show us how we're going to move forward in that space.
Okay, well, Michael, I'm sure you have something to say about that.
Yeah, so I agree by this vehicle to X, but I'm not so sure that if this is the only one dominating topic. So I would say that we are quite good, for instance, with European vendors on the charging infrastructure side and how to integrate and connect it, for instance, with grids. But where so it's we're a little bit struggling also with having products that fit to different world regions with different requirements. So this, I think, so it would help if the European market is more uniform than it's today. But for sure, so I think on the business model side, having innovative business models, there's some improvement or some potential for improvement within Europe. Probably in other market areas, they are more innovative in this way.
And I think that, just to bring it back to the next generation IoT framework, there are a plethora again of open calls that are there to stimulate new applications and new actors coming into the scene and engaging with these large-scale pilot environments. So again, encouraging anyone who's listening either here today in person or later on during the when we post it online to really kind of connect and find out what those opportunities are. Damien, what's your perspective? I mean, hopefully you can see it also from, okay, what does the UK not have? What is it that Europe offers over and above what other regions can offer?
So I think the UK has done quite a lot in terms of innovation in this area, and it is part of the strategy, the government strategy, as I said earlier on, around the net zero innovation portfolio, making funding available for a number of different projects. And I think what is quite interesting that what we're learning through this isn't just applicable to one market or one country. What we're learning can be used and is applicable within other jurisdictions. There's no reason these models won't work elsewhere at all. in terms of the edge itself, we're talking about edge and where we are in terms of the rest of the world. We're seeing a lot of usage. We talked about Canada, but obviously US themselves are heavily invested in edge. I think currently $2 or $3 billion investment per year in edge, and that's likely, well, predicted to increase time over time. And Europe are only slightly behind that. So we can see, Europe are sort of in that same sort of league as US and Canada, and the rest of the world has a similar sort of share. So I think we're relatively well placed in terms of where we are with edge and our understanding and usage of it, running lots of these pilot schemes, doing the learning, running these proof of concepts to understand more about edge. Hopefully trying to clear the picture a little bit. It can become quite muddy. It's quite a complex arena. I think a lot of it comes back to data, understanding, extracting information from the kind of mesh networks, all the devices connected to these networks, making use of that data to improve the consumer life. I mean, when we talk about digital transformation, we always center it around the users. So ensuring that people are taken care of, are thought about first and foremost, and build it into that kind of a model, I think.
Thank you. So I think at this point, I'm going to ask, I think, Valentina, if you can, we have an anonymous attendee. If you can just identify yourself and you can perhaps ask your question, and Valentin, you can enable the functions that they can speak, please. Would that be possible?
I think that it's better if they raise their hand, so I can.
Okay. Yeah.
We can start with the next question, probably.
Okay. Yeah. Okay. So meanwhile, the person who posted the question on the legacy cloud system, if you could raise your hand, and Valentin will then enable you to ask your question live. Victor Banos, and I'm not quite sure what that is. If Valentin, if you could allow that question to be posed, that would be fantastic. Victor, you need to unmute yourself now. You have the floor.
Hello, good morning.
Could you put your camera on, please, so we can see you? Thank you. Okay, don't worry about the camera. If you can just ask your question, that's fantastic. Thanks.
Hello, good morning. Now you can see me.
Could you just tell us where you're from, please? What your company is, or what your affiliation, so we can kind of have some context for the question. Thanks.
Oh yeah, I'm Victor Banos, and I'm from Fortis in Munich. And I would like to ask to the panelists if do you know any large application that has been developed already in real scenarios? I mean, yeah, that it's already running in a city or on a company that the final users are using right now?
Thank you, Victor. Are you talking about EV charging specifically?
Yeah.
Okay. Does anyone want to take that question? Go ahead, Laurent. Yeah.
Yeah. So
thank you, Victor. Yeah.
Francesco from Emotion. Are you referring to some kind of demand response services commercialized, or are you referring just to a CPO, so an e-mobility platform to perform the charging station?
Yes, I'm referring to the mobility platform that it's already prepared to do this.
Oh, okay. We already have commercialized our e-mobility platform. So Emotion not only produce charging station, but is also a CPO. So we have an electric mobility platform. The name is Spotlink, and allow the charging station to be controlled remotely and monitored in real time from the owner of the charging station, because we sell the charging station to users, and so we let the users to make business with the charging station acquired from Emotion using our platform. Of course, we yet not integrated the demand response mechanism in our platform, because we are investigating it in our IoT Engine Project, in the research project financed by European Commission. But our goal is, of course, to integrate it after the end of the project. So it's something that we will be commercialized after the end of the project. And of course, we also are involved in other projects. Very interesting also, a project named Hyperride Project, where we'll test a fast charging station, bi-directional charging station, so with the V2G functionalities. And that charging station will be deployed in a DC microgrid that will be connected to an AC microgrid. So will be an hybrid AC-DC grid. And in that way, we increase the efficiency of the interaction between the renewable energy plants and, of course, the flexibility provided from the charging station and the battery energy systems, to reduce also the peak power of the local grid, and so to increase the efficiency of the local grid. This is also very interesting, and we will also provide this kind of smart energy systems, smart EV charging system at the end of that project. So
thank you, Francesco. Thank you, Francesco. Laurent also had an answer to Victor's question, and then we'll pass on to the next one. Thanks. Thanks both.
My answer is maybe not relevant to the question. It was more in the residential space, and so that was related to the use of V2x in the residential space, coupled with self-consumption and edge IoT, and that's the use case which we've been working with Decibel. And the maturity is that the product is right now launched in California, is going to be launched in September, and I think it's going to start to scale early next year. So I think it's still still early stage in a way, but we see it close to industrial maturity. What is missing is really the real-time price element, as what we were discussing.
Thank you, Laurent. Thank you both. So I think that the next question, and the anonymous attendee, we haven't been able to identify them, but the question is, if virtualizing the legacy cloud system and applications, does that not pose a risk for cybersecurity, or can it be bridged easily to the more modern services and systems provided by the next generation internet? Who would like to take that question? So, Laurent, yep, go ahead.
Maybe just from the side of the backend, because I'm coming from that environment, and my message is, I do see the two worlds actually converging from a technology standpoint, because the backends also virtualize into containers right now, and that's going to facilitate, I would say, connection between the two worlds. Still, the definition of the interface is very critical, crucial from a security point of view, because it further expose the surface of attack and the cybersecurity becomes much more an issue. So we cannot neglect. It's going to be more complex for grid operator, but it's what is needed for the sake of the system.
Thank you, Damien. I think you wanted to say something as well.
Yeah, I agree with that. So it all comes down to best practice, I suppose. And when we look at these things, everything, I think we mentioned it right at the top end in terms of securing by design, right? When you're designing solutions, you're exposing these new interfaces that Laurent talked about. You do that by design rather than as an afterthought, and you make sure you put best practice in place. You make sure you conform to well-known security standards, and then you back that up by making sure that you're adhering to those standards. So risk assessments, make sure you've got your DPIAs in place. And then those are regularly checked off by independent assessors. So I think it's a mixture of all, but yes, clearly there are risks. Then there's more attack vectors. But if you design things in the right way and secure things properly, then we can mitigate many of those.
Thank you. And I think on that particular point, I would like to pass on to Dolores and to Marion Malafos, who's the policy manager for the Smart Energies Network, which is actually an industry association. Before passing on to you, Dolores, I would really like to thank the contributions of Michael, Lon, Damien. It's been an absolute pleasure to hear from you all. I'm very much looking forward to our next discussion. I think there are so many topics here that we need to unpick further. Very much looking forward to that next opportunity. Dolores, over to you. Thank you.
Thank you so much, Tania. I think it has been a very nice event with very nice insights, so very interesting. So just for wrap up, and then I will pass the floor to Marion. I think we can mention so very interesting key points. So at the end in the session, we had these two main sessions or blocks in which first we learn from the experience of the IoT Engine project, in which first we learn how this decentralized IoT, this next generation internet can heavily support these microservices that will ensure the scalability, which is, I think, is something that was mentioned along all the sessions. So together with this privacy preserving mechanism that perhaps will be more secure using the edge. So I think there appear a lot of very nice points that should be taken into account. And then very important that this energy balancing. So at the end, we have in the grid energy consumption and energy production. And we have to check how this what it was this former unidirectional flow will become this bidirectional flow, because at the end we are generating a contact among the vehicle and the charging station. At the end, this has also an impact in the grid in general. So energy flexibility, it's a key issue in there. And it's also directly with the real time. So it is very important related when we go to the market and to link it with the micropayments. And then we were learning about the importance of the data analytics, and this federated data analytics, and how this edge could support also this gathering of very important information that can be computed in the edge and then also sent to the cloud to generate this ecosystem in which the different actors in the energy and mobility value chain are exchanging this important data. Because at the end, we are discussing in an ecosystem in which all the different energy sectors should be integrated. So it is very important to ensure the resilience of the system in a period in which we have to be prepared for this massive deployment of electrical vehicles. So this exchange of best practices and learnings and knowledge that we are having in the different countries, and I think we have to be very grateful to the high-level speakers that we had today, because they brought very interesting insights on how this could be can be done. So we are in this unprecedented moment, because at the end we are seeing that it's going to be a huge deployment of electrical vehicles, but at the same time we're seeing that perhaps in some countries, or which is the velocity of the infrastructure. So the speed of the deployment is not balanced with the needs of the infrastructure, and this is important also in terms of the market. So there is a change, and the European Union is working a lot on that, on how to put consumers in the center. And this is important to orchestrate the market and also the transactions. So for that, the real-time information, it's very important, but also the inclusivity, because we have seen also that it's not the same the e-charging station to be deployed in an urban area and also in rural areas, in which perhaps also the energy providers are not at the same stage that in the urban areas. So we have seen which are the difference in the application in the edge for the electrical vehicles, and how the car and the charging points are key issues that should have also an important role related to cybersecurity. So at the end, a huge amount of data is going to be shared. And as it has been mentioned, we cannot bring fire to house, because at the end, the vehicles are going to be these instruments in which we are sharing data and be connected, and it's part of our day-to-day life. So the market regulation, it's a barrier. So I think it's not just everything about technology, but it has been nice also to hear what's happening at global level and how the different actors are evolving to generate this more balanced ecosystem that will be possible, this faster deployment of the electrical vehicles. This is a general wrap up of the different sessions and the different contributions from the very good speakers that we had the possibility to listen today. And now to close, I'm going to leave the floor to Marion Manafos. And thank you, Marion, and you have the floor. Thank you.
Thank you very much, Dolores, and thank you all for the interesting presentation this morning and the debate. So, Dolores, you made a good summary and wrap up of the discussion, so I will not paraphrase. But what I take from today's discussion is that we need to have a digital infrastructure that looks at the consumer side. So we need highly innovative use cases that are enabling consumers' participation. And so for that, we need also to be able to connect the different environments from consumers, from the device level, towards also energy service providers, also other market actors and system operators. Just maybe before, I should have started by that, but I'm a policy manager in Smarten, and Smarten, we're a European business association where we are pushing for consumer-driven solutions. So we create opportunities for cars, business, industries to participate actively in the electricity system, which allows to support the integration of more renewable energy. And that is indeed specifically when we talk about electric vehicles. This is an area where we also need to have data-driven energy services to help with the integration of EVs into the system. Because we are seeing a massive increase of EVs. There is also a strong push at European level to accelerate the role, the deployment of EVs, but this can lead to a stress to the electricity system. With more electrification, there is indeed a potential stress, but there are also important opportunities, because through electrification of end-use sectors, we can integrate more variable energy. But if we want to really optimize the system, we need to allow electric vehicles to become flexible and smart assets. This was also clearly shown in the discussion today, where we're seeing the need to have an energy system that is more decarbonized, more decentralized, and this can only be done through digitalization. And so we need also to support the smart interaction of behind-the-meter assets with both grids and the electricity markets. And we see a lot of potential. Even the Commission itself, in the energy system integration strategy, is saying that EVs could provide up to 20% of the flexibility that is required on a daily basis in the energy system. Actually, much of it will happen in buildings at the residential level, but EVs can be a great source of flexibility. And we can push further also with V2G or V2x, where there are significant benefits that can be unlocked for the grid, because the EVs can become a buffer for power variability, but also for the EV and the user itself, to help reduce the carbon footprint of the consumers, but also help to optimize the cost of a recharging session. But for all of that to be feasible and to become a reality, we need to have data access. We need to have real-time or near real-time data to know when it is best to activate the flexibility of the EV, when it is best for the system, but also for the consumer itself. And we see that, I mean, this morning, and I think it was Francesco mentioned it, that we see different level of communications taking place between the GSO and between the different level of the EV ecosystem. And these communications required data to be read, to be understood, and used at these different levels. And in Smarten, we have set out a recommendation to have a digital ecosystem that really supports data-driven energy services. And our request is basically to have a bi-directional flow of data between the grid, the prosumers, going through the different level of the ecosystem. And we see a need to have a decentralized data exchange architecture that is covering data processed at the periphery of the network, as close to the originating source as possible. And so in Smarten, we have been looking at three priorities. The first one is to look at prosumers data. So we look at which data are needed on the consumer end. So that includes grid edge, IoT sensors, and how we can share this data. Of course, making sure that consumers' ownership and data privacy are secured. The second element that we're looking at are the grids and market data. Today, we need to know what is happening on the grid. Energy service providers need to be aware of what is the grid situation, what is the market situation. So we are advocating to have easy access to data from the grid operators, notably. And then, of course, our third focus, and this was also mentioned today, is related to cybersecurity. Because with the growing number of decentralized energy resources, for instance, EVs that are connected to the system, there is also a rising question and topic of cybersecurity also at the consumer end. So I've also been asked for these conclusions to look at what could be the policy developments. And so this is a bit the priorities that we are advocating for in Smarten, but this can be also translated into policy, regulatory framework at EU level. And the first one, which is actually the starting point, is to promote the uptake of digital technologies, including in the transport sector. So that means promoting smart and bi-directional charging for electric vehicles. And that we see some opportunities indeed through the Fit for 55 package to have specific requirements in the Renewable Energy Directive, but also the Energy Performance of Buildings Directive, because actually that's where also we will have a lot of potential in the residential sector. We also need to have grid edge solutions that are able to communicate among themselves with the users and with the energy service providers, as well as with the network. We need to ensure that smart assets, so decentralized energy resources, are not standalone assets, that they are truly integrated into the system. And so we need to have data sharing obligation that allow these assets to be communicating with the overall system and to receive information from the rest of the system. And what we see today is that until now, a lot of EU data policy has been very much on smart meters. So we need to broaden the approach to also include the sub-metering data level. Because we see that sub-meters, IoT sensors are becoming an increasingly important source of data to provide real flexibility measurement. So what we're saying is that we need to look also into the interoperability of data at the sub-metering level. And to extend a bit the discussions which are very much focused on the smart metering level. And that is notably what the Commission should be doing as part of its expert group on interoperability of data. And then what we see as also important is to look at the creation of a European energy data space that would develop free flow of data. And here again, interoperability is a keyword. But first, we need to have, as a first step, data transparency. We need to have access to data from the system operators, market participants, as I mentioned before, they need to be aware of network constraint information in real time. They need to know about the status of the energy mix or the greenhouse gas energy content, because this will provide useful information and signals to when to activate flexibility. And we see that we have different starting points between TSO and DSO, and we would actually encourage the DSO also to look into what is happening at a transmission system level with the data transparency taking place at the TSO. And once we have this transparency on information and more access to this information, we need to ensure that the data is accessible in an interoperable way. And we see that interoperability is needed between the different marketplaces, also between the data exchange platforms. And on that, we also recommend to look into some standards using the SIM-based standard, i.e. 62325, which is also being used at the TSO level, and that can also enable interoperability and ease market entry to new players. And then also we need, of course, to look at the interoperability between the marketplaces and the data exchange platform, so that we also have integration between the physical and the digital layer. If we manage to do that, we will allow market players to enter the different marketplaces. We will ensure that we have also better coordination between the transmission and the distribution level. And then finally, we need to advance on cybersecurity. And this is indeed a crucial element when it comes to the charging infrastructure of EV, because that can be also an entry point for future cybersecurity attacks. And so there are a lot of development at EU level with the NIS2 directive revision, but also the cybersecurity network code. I think what is key is to ensure that we have cybersecurity requirements that are defined according to the risk that the assets is posing to the system. So it's basically a risk-based approach. And that is something that we would also ensure proportionality of cybersecurity requirements and ensure that we have a high level of cybersecurity requirements across the whole energy system. So just to sum up my intervention, but I think what is key is to really, the key word here is interoperability of data, and two levels are critical. First, we need the fluid interaction between the prosumers and the energy service providers. So in that sense, data portability is key, and we have a lot of expectation in that regard from the Data Act, but also the Digitalization of Energy Action Plan that the Commission will propose in September. And we also need interoperability between the system operators themselves and with the markets as well. Because if we don't achieve interoperability at the different levels, the market risks to remain fragmented, and prosumer business models, and in the end prosumers themselves, they will not be able to enjoy the full benefits of electromobility fully integrated into the energy system. So we really need to push forward to have a new energy and mobility services supported by data. Thank you.
Thank you so much, Marion. I think you have put very, very interesting points, and I think that, as you mentioned, that the interoperability and the possibility of develop these new services to avoiding these fragmented markets are key points. So we are on time, so we have been very sharp with all the sessions. So thank you very much. Thank you very much to all the participants. It has been a great session with very interesting events and very nice interventions and point of view. And we would like to remind you that those are a series of community events. Thank you so much for NGIoT to promote the organization of this event. I think it's very interesting to start discussion on that, especially as Marion has mentioned, to try to avoid this fragmentation, to align all the actors, and also to push all together this European market for the electrical vehicles. So thank you very much to everybody. As Tanya has mentioned at the beginning, this session has been recorded, and all this information will be available on the website. Thank you so much and enjoy the weekend. Bye.